The picture that you saw there, Mark just showed, was of the Museum of English Rural Life, which is a museum about English rural life in Reading, and it got some lottery funding a couple of years ago to allow them to move out of a sort of scout hutty thing or some older building in the area of Reading University, and to have a dedicated special property built. And they've got some really good galleries, and they host now Ladybird book collection, which is also quite fascinating for those of us who were brought up on Ladybird books. But the project, one of the scientists contacted us at the Makerspace in Reading and asked if any members were interested in helping do some technology, and it happened to coincide with the Things Network. So they have great difficulty getting Wi-Fi out into their garden area, and so they said don't think about trying to use Wi-Fi because the hospital is right next door and there seems to be so much radio crap come out of the hospital. We don't know whether it's MRI scanners or what, but Wi-Fi wasn't going to be an option. So it looked well about using the skills we have at our lab and the Things Network, and myself and Richard, another member, it coincided with our interests. So one of the things we've always said is we want to have projects that are open licenses, use as much open source tools and utilities as possible. And Richard was particularly interested in trying to get some proper uses for the microbit, which was being distributed to the schools at the time. I don't know how many of you know about microbits. Yes, you can come have a look at the one that's here. And so Richard built the LoRaWAN shield, and using these tools, KiCad, GitHub for putting the code up, the idea that the schools could repeat the project. The bed was one of a number of raised beds, you see at the top here, and it was cleared out of soil, and the plan was to grow sugar beet, because sugar beet was an important crop for East Anglia over many years. And the seed is still sort of a licensed seed. You can't just go and buy sugar beet and seed and do it, because they want to track it for disease and genetic modifications and bits and pieces like that. But it hadn't really been studied by any scientists properly, and the scientist Robin from Australia decided that it would be one of her side projects. She was doing other projects as well. So we did a bit of a design, said what could we do, and we looked at doing temperature, moisture, and other parameters. And then we wanted to get it up out of the way because the garden is used by a lot of what they call the Friday fledglings, who are a lot of small ones that come and play around with the beds. So we wanted to try and get some of the stuff out of the way of them. So we set up a timeline from 2016 towards 2017, doing the planning for the for the soil to be done, put in the sensors ahead of that time, and then crop would arrive, grow over the season. We weren't quite sure exactly when it would be harvested, sometime later up to October. In fact, it was August, or the end of August, when it was actually ready for harvesting. And then there was a layout of what was actually going to be sensed. So we've got here the BBC Micro and the controller on there. One of the reasons we chose it is because it's very low power, which matches very well with what LoRaWAN, the low power element of LoRaWAN. And then using Grove connectors, which are a standard serial connector system. You can buy lots of standard sensors. And I'll pass this around. This is a display we made up to take to the Things Network conference. And when we sent it over, the idea being that people could see exactly what's going on, carefully laid everything out. And then when we got there, it was actually this way round. And people wondered why we had a LoRaWAN connected spot welder. But I happened to reuse a laser cut enclosure to do it. So when we got there, we had to pull it off and stick it on the correct way round. So these are the various things. We can have up to 255 different sensors on the serial link. And then there were some soil sensors, and you'll see there's a silver cylinder on there, which is the soil temperature sensor. So that's the microbit and the shield in place up at the top, and it connected to the local network. We have in fact got the world to deploy their own gateway. One of the challenges has been getting it connected wired to the university network, but we were able to actually put it close to an access point. Power system, we also plan to use image technology based on the satellite things of looking at fields to try and work out with different infrared filters, and that would require a Raspberry Pi because it was going to do image processing, which the micro:bit wouldn't be suitable and LoRaWAN wouldn't be suitable for. So the idea was to have, we experimented with it. We didn't find that we got the right frequencies of infrared light with the standard Raspberry Pi camera and the filters we had. But that's a project that we want to pursue a bit further. And that was how this system was working with a filter. We actually only had a single filter initially. The idea was that had the filters worked, we would have had them on a wheel so we could have a look at different colours of health. We then built a dashboard which is available up via a browser or via a mobile phone to look at the various parameters. And this reuses something called the Open Energy Monitor dashboard widgets. And Open Energy Monitor is another open source project, which I know the people who created the project and was pleased to be able to try and reuse theirs for a different purpose to show how flexible their system is. They also store the data, and then this shows, I was particularly interested in how the battery would decay over time. It just has the two cells on it, and just used a couple of cheap cells. They last, because we're sending about every half hour, and it also has the LEDs indicating some information, tell people what's going on. We weren't expecting them to last more than a few months, and in fact that's sort of how they last. Then we've got the graphs showing, and that's a flexible graph. You can choose days, weeks, and some links to the YouTube video explaining what's going on. And this is the end of the season. The crop was looking very healthy. Just after this, they all started dying off on the leaves, telling us it was ready. And then they were harvested. We ran all the sensors down the centre so that they were able to pull them all out without disturbing the sensors, so the bed can be reused. And all the data collection was done electronically, so it was just done the old-fashioned way and gave us a good sized crop, which went off and was used for creating some sugar by one of the agriculture scientists who was helping with the bed. And then we looked to see what we're going to do for this year, and we've actually got another group of students from the university coming, and they're going to take a bed next to the bed we've got and do a comparison crop between combination planting to be able to put things like nitrogen into the soil. So I'm looking to see if we can find some sensors that will actually be able to detect nitrogen levels on a dynamic basis rather than chemically based. And a lot more sensors are becoming available. That's been one of the great things about the focus of Internet of Things, is that a lot of scientists are looking at actually making automatic sensors for diabetes, for soil, for agricultural purposes, for marine purposes. And they're coming down in price, and one of the big drivers of that is the mobile phone itself, which has things like accelerometers and all the other devices in there. So they're our contacts, and that was the end of mine. Got any questions? I've got the other bits, pieces if you want to have a look.